Hello, what else? My name is Diego Nieto, and I was giving paper number 2. Show an approach to developing high-performance concrete with dense structure based on the rheologic point of view. Then the document shows a series of experiments and modeling. A high-performance concrete is a new type of concrete with excellent mechanical properties, high tenacity, and excellent durability. For the development of this style of the concrete, a series of compact particle packing theories are used to obtain a dense particle skeleton. Therefore, this style of concrete is not only different from normal strange concretes is in mechanical properties, but also presents variation in the chemical properties since it is an agreed amount, cementations, and superplasticizer materials, and in the same way in lower proportions of water. The viscosity of high-performance concrete tends to show high values, which makes it relatively easy for air bubbles to become trapped during the production process, causing the mechanical properties to be reduced. Therefore, the approach of reducing the content of the trapped air bubbles is of great importance to improve the properties of this of concrete. At present, there are mainly two approaches to reducing air bubbles in the concrete: physical vibration and tamping, and chemical methods, addition of the former. Because these methods are neither efficient nor adequate for this style of concrete, this study attempts to develop an advanced high-performance concrete with a dense structure based on the rheologic point of view. Regarding the materials, the cement P250 and 2.5 cement used for the manufacture of high-performance and high-performance concrete was used. Some supplementary cementitious materials such as fly ash and silica foam were also used. Natural rubber sands was used as fine aggregate. Super plasticizer is used to improve the workability of the concrete. The former was used a GTAM P803 to eliminate air bubbles. And steel fiber will also use regarding the methods used we have. The base design method is the design using MATLAB to adjust the radius of the edge material to achieve the best value between the synthesized mix and the target carbon. Additionally, to produce auxiliary concrete with different viscosities, the cement is replaced by silica foam with different levels varying between 0 and 30%, and fly ash with different levels between 0 and 16%. To determine the wet packing density, a series of equations are applied that take account the density of the water, the density of different solid materials in the mixture, and the value ratio of different solid materials. After this rheologic property, the study carried out and is mentioned that it's one of the most suitable methods to investigate the fresh behavior of the cement-based materials. In the experiment, the rheologic energy test was used to measure viscosity using a shear speed rotor. This instrument is the one shown in the picture on the right side. The rotor is inserted into the container containing the paste in the made rotate at different speeds, and the program gives the information in the form of the relationship curve of the shear stress and the plastic viscosity of the mixture under the chain of decreasing speed. Additional mechanical properties that are carried out there consist in that after the samples are cured, they are subject to the axial tensile test. A digital imaging correlation method is also used to monitor concrete sample reaction of the crack development during the tensile test process. Finally, an imaging analysis study consists of counting the samples into a series of places with a size of the approximately 40 mm by 40 mm by 20 mm, and they find porosities with mineral powder, so they obtain real contrast with it through a superfine microscope. The data picture to the surface is seen in the image to the right side. As a result, the rheologic modeling of concrete based on dynamic modeling of air bubbles is a way to sustain that is in this case of the air trapped inside of fresh concrete can be guaranteed if this viscosity is below the 0.59 Pascal per second, which means the bubbles can be removed efficiently without vibrations. We are beneficial to the properties and construction efficiency of high-performance concrete. Regarding the methodologies that adjust rheologic characteristics of concrete, it is stated that when the county the superplasticizer at this is a property 3.5% for this study, the trapped air bubbles could be easily eliminated, and therefore much denser concrete can be obtained. On the other hand, with the increase in the silica foam content, the plastic viscosity of the mixture increased sharply, and the way the fly ash increased, the plastic viscosity of the suspension decreased. Now, as for the parameter of the air bubbles of concrete with different viscosities, it is observed that viscosity is directly proportional to the diameter as well to the amount of air bubbles of the observed in the figure 9. Regarding the validation of properties of the optimistic concrete, the compressive strength of the optimistic concrete obtained can reach approximately 170 megapascals. It also observed that optimistic concrete treatments proposed in the study restricts our apparent of air bubbles of the great strange. As conclusion, we can highlight that viscosity should be controlled in an optimal range so that trapped air bubbles can be removed efficiently without the need for vibrations. Both pre-plasticized and supplemental cementitious materials can be affect the viscosity pressed concrete. In this case, there is certain value with which the viscosity can be controlled in appropriate range in the administrative air bubbles. Based on the theology of close particle packing and the boundary conditions of the raw materials and optimistic concrete, with a relatively low viscosity it can be designed, and future with an appropriate addition of the former trapped air bubbles can be effectively reduced just within the tour can improve mechanical properties. That will be it. Thanks for your attention.